Now we have a whole pipeline for learning. We start from data, we get features, we have a mathematical model, we train this mathematical model, or make it learn from the data, so that way it's able to predict 0 or 1, where we interpret 0 as apple and 1 as banana. That works perfectly fine, except we only had that for a single input, right? If we only have one input, we can use the pipeline we just created. That's great. But in most cases, you want to use a whole lot of data to be able to train your machine learning model. So the next thing we need to do is to discuss the neuron, which is how we go from one data point to many. So remember we have the sigmoid function. Sigma of x equals 1 divided by 1 plus e to the minus w x plus b. And so when we input an x, we get a value that's between 0 and 1. Now what if we instead had an x, which is equal to a whole vector of values? We have x1, x2, dot, 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 where we say like the first value, this x1, is the average amount of green in the figure. The second one is the average amount of blue, and we can have the height of the object in the picture, we can have the width of the object in the picture, we can have a whole bunch of these values, and that's a whole vector of numbers, which is for a single data point. What we can do is we can improve our function to allow all of this data to go in. The way that we do this is to, instead of using a single x, we have a weight for every x, and we put them all together. So we have minus w1 x1 minus w2 x2 minus dot 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 plus b. So we have a weight that we associate with every x, and we add them all together, we add this bias to it, and that is our scalar output. So this right here would get cumbersome to write out all the time, which is why it actually has some nice notation. So if we said that our w was a vector of w1 through wn, then this thing called the dot product is defined as being w1 x1 plus w2 x2 plus dot 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 wn xn. So it says take this first value of w and this first value of x, multiply them together. You do that with every single part of the vector, and then you add the result. Using this definition of the dot product, we have a much more succinct way of writing the same exact thing, which is sigma of x equals 1 over 1 plus e to the minus w dot x plus b, where now this operation is allowed to take in n, or infinitely many, different data points and scrunch it all into a single number between 1 and 0. And then the rest of what we've talked about before still applies. You can train this function to match your data by changing w's around, changing b's around, until you get the correct value between 0 and 1 to match apples with apples and bananas with 1. Now, the next thing that we might want is, well, a neuron takes in multiple values. Can we create a neuron that takes in multiple values but also spits out multiple values? The way we do this is through a matrix multiplication. So now let's say that this w is w11, w12, it's a whole grid of values, wn1, dot dot dot. So it's a whole 2D grid of values. We can define this operation called matrix multiplication, where w times a vector x is, you take the first row of w and you multiply it against the whole column of x. So w1, 1, x1 plus w12, x2. Notice this is just the dot product of this row against all of the x's. w1n, xn. The next row in this output, or the next value in this output, is just the second row dot product with the whole column of x's. So w21 x1 plus w22 x2 plus dot 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 plus w2n xn. And you can do this at every single point. So the row dot product with the column gives you the first row. This row dot product with all the x's gives you the second row, and you do that with every single row in the matrix. If we then write a neuron, which is 1 over 1 plus e to the minus wx, where this is matrix multiplication plus b, then this is a function which now takes in n many inputs, and it spits out m many outputs, where m is the number of rows in the matrix. This is what we call a neuron. So if we had 4 inputs, we can make the next layer have 2 outputs. And the way that we do this is we say that we have one of these functions where this w has 2 rows. So 4 things come in, 2 numbers come out, and that would correspond to this function having a matrix with 2 rows. And so this picture right here that we show about neurons is simply showing how their input-output structures look like. And their activation function, what that activation function is, what this picture is corresponding to, it means that there's a function in here, the sigmoid in the background, where you add things together using matrix multiplications, then you apply a sigmoid to every single value, and then you go on. So this is what we call the neuron, and this is going to be the building block of our neural network.